The last example of the 2-4 notes that we went through. I'm doing a whole screen recording because I want to go back and forth with this shoe print length thing that we graphed yesterday. So here we go.
We don't have video.
You can't see. You can't see. They can see. You can't see.
You're not there. Or like how you were trying to get
You just
this.
need to wake up. Okay. All right. So yesterday, you guys filled in this equation, the height equation, and we said shoe print length is based on height, or height is based on shoe print length. So you put your shoe print in there in centimeters. Each one of these is in centimeters, and then it'll spit out your rough height. And that said it had an R squared value of 0.35, which we took the square root of, and we got 0.592. Now, let me point out some things that your homework assignment calls on the homework assignment that might be like, what the heck is that, okay? When they ask for a critical value, okay, they are asking you to look up this chart, and this chart tells you what is acceptable. What should the R value be? What should the R value be? That is your critical value. So in our shoe print length, we had 5 numbers, which means our R value has to be 0.875 or 0.878 or better. Okay? Now, on the homework assignment, think of this as a number line. Your number line will go from -1 to 1. 0 is considered to be a bad R. -1 and 1, the closer it is to those, it's considered to be a good R. Your cutoff marks are going to be here and here, and those numbers are going to be that critical value that we just looked up on the table, 0.878, 0.878, and -0.878. It will count you wrong on the homework assignment if you only put the positive one. So you need to put the -1, comma, the positive one, or vice versa. You have to put both of them, otherwise your homework assignment will count it wrong. It is very picky. Okay, you have to have both of those things there. So what is considered to be, so this really splits your number line into 3 regions, right? You have this one here. You have the numbers in between there, which is considered to be a bad R, and then you have good R's over here, okay? This is good positive relationship. This is a good negative relationship. And then these are bad linear relationships. So your R must be either greater than 0.878 or less than -0.878, okay? The R that we got yesterday when we did this, when we divided it or took the square root, was 0.592. He is abouts right there. What does that tell us?
Bad.
It's not a good linear relationship. It could be related some other way, right? But it's not a very good linear relationship according to this. Now, if I add data points, let's say I did 12 data points, we're given a little bit more leniency, 0.576. And if this was the R value for 12 data points, it would be acceptable, right? Because that number is greater than 0.576. That would have worked, okay? So, but for right now, we have that, and that's not going to work, all right? Go to example 6 on the back side. Here we go. All right, on the back side, they got this equation for height and shoe print length, okay? Our height, I'm going to repeat this on the back side. Our height that we got was 125. I'll just do 125. I'll write it the way that they did. Plus 1.73 SP. They got 80.9 plus 3.22 SP, okay? Now, the reason why they got different than us is they used all 40 pairs of data, okay? There is a bigger table besides this one. This one only had 5 of them on there, okay? They used all 40 pieces of information, and they got this equation instead. Which one's more accurate?
Theirs.
The one that they have, right? The more data you collect, the more accurate you get, okay? So that is why there is a discrepancy between the two that we have. Like, this is what we got, and we did it correct, right? We got that from this table over here where we did the scatter plot, okay? And the equation, we got the equation and the R squared value from that, okay? That's fine, we did that correctly, but the height and shoe print equation that they got is from the 40 pieces of information, okay? So it says, if the graph were extended to the left, the regression line would intercept the actual y-axis at a height of 80.9 centimeters. So even though this scatter plot line only goes from here to here, like they've stopped it here, the y equals mx plus b form that they have, like this is y equals mx plus b. They've written it like that instead. Our slope is 3.22, okay? And our y-intercept is 80.9. So if it would connect on down, it would intersect at like 80.9 or whatever they have, right? And there is that, okay? This slope of 3.22, what does that mean? That is the slope. What does the slope mean?
It's
If the slope is
equation of the
3.22,
line.
okay?
The equation of the line.
Okay, according to the height and the Shouprint length, what does that 3.22 mean? This is like 3.22 over 1. Okay, so what does that mean? It goes up 3.22, which is the height, for every 1 centimeter of shoe print. So for every 1 centimeter larger in shoe print, we are 3.22 centimeters taller, basically, according to this. That's the slope of that. You might have some questions about that as well. Yeah?
Mm-hmm.
Good?
Mm-hmm.
We're listening really great this morning. All right, anyway.
Mm-hmm.
Okay, that is all I have. You are free to do as you please. Don't ask me any questions.
Wait, was that a for real compliment?
Oh my god, it's like
Can I have
No, I am so sarcastic